Hi and welcome to this video in the MRDCL Understanding Concepts series. In this video we're going to look at the principles of reading and writing data. You'll find the files used in this video in the folder DAT104. So we're going to start with a very simple example, and we're just going to look at and understand what start data, finish data do and read and write do in MRDCL. So we've got a very simple data file here. It's only got a couple of lines in it, so let's open it up. File 1. So there's 2 lines of data in here, which really just go from 7 columns. 001 is the first serial number with 444, and 002 has 555. So it couldn't be much more simple than that. So what actually happens in MRDCL when it's reading data? Let's understand the principles. Now this sounds remarkably obvious, but it's worth just understanding these principles. So what happens when we have a script? The start and the finish data are normally the commands, if you like, or the lines in the file that are telling MRDCL to read a line from the file, process it, get to the finish data, and write that record to the IDF. Then it clears all the variables, goes back to the start again, gets the next record in the file, processes it, and writes the finished data at the finished data point. And we can see that when we run, that in that file we've just run on, we've got 2 records written to the IDF that were accepted. Now, you can take control away from MRDCL so it doesn't read and write just based on the start data and the finished data. And indeed in this script here you can see I've got a command that says read $1 to 100, which means that it's going to read a line from the file based on that command. In other words, the start data is nothing more than a start to the file, or the stage of the run, but the read $1 to 100 is actually reading the data. And if I were to read less columns, if I only read the first 3 columns, for example, it wouldn't know anything about the 4th column, which we got question 1 in, and we'll get a blank table. So if we run that now, it'll work, but we get an empty table because the read command is replacing what would happen by default, and it's only reading the first 3 fields. So we need to set that to be long enough to read the whole record, which in this case is 100 characters. But if you had a very, very long record and you only wanted to read perhaps the first bit of it, perhaps there's lots of addresses or other text on the end that you don't want to waste your time reading, that would work perfectly fine. The card character statement here is set to 100 characters. The maximum length that you can have is 99,999. So that's the longest line that you can read into MRDCL. If you have a line that's longer than that, it does happen these days when you're exporting perhaps from an online survey where you've got lots of text and huge text fields that have been allocated, the data can go beyond 99,999 characters. There is a free tool that we supply that will break your lines into 99,999 in length, or less if you wish, so that you can read multiple lines with an MRDCL script. That's not particularly covered in this video, although you'll see some of the techniques that you'll use to do that. But it's perfectly okay to process effectively a record length of any length by running it through a short process beforehand to split the data up into more manageable lengths. And indeed, I'm actually very against reading lines that are too long, because you actually get to a point where most editors won't read a line that's longer than a certain number of characters. They either crash or hang. I have found 1 or 2 bits of software that can read it, but most editors will not be able to read a line that is ridiculously long, which means that you can't actually inspect the data and see what's going wrong if you've got problems with your table. So it's better to output 2 files with the data in 2 different files, and we'll be looking at that in one of the other scripts in this particular video shortly. So we're reading here 100 characters from the data file, and then having done that we can then process it as you would expect. You can, if you want to, read different parts of a field off here. I don't recommend that. I usually like starting reading from field 1, otherwise it starts to get confusing to manage. So I wouldn't recommend starting at 11, it would get quite confusing to work with. And then when we get down to the end, the finished data here is the command that's writing that record away. And if I were to put a write command in, that would supersede the finished data, and the finished data would just be the end of the stage, rather like the start data has become the beginning of the stage only now when I've got a read command. And so when I write, it will make no difference here. It will produce the same correct tables with 2 respondents, but it does mean I can do some things to that write command to control things a little bit more if I want to. And just to show this perhaps in action is to show what a write command does. If I put the write command in there 3 times, I don't recommend this, I would effectively get 3 times the number of records for my tables. There you can see 6 records, and now I've got the same 2 records replicated 3 times. Obviously you wouldn't want to do that really, but it just exemplifies what a write command does. But you can also filter a write command. You can't filter a finished data to say I only want certain records to appear. You can actually say that I only want to write them away if they've got answer 4 at question 1. So the record that had answer 5 won't get written. And now my tables have 1 record in there because the respondent that had a 5 has been suppressed effectively or ignored because I've got a filter on that statement. I'm going to take that back off. Now the other thing that works with reading and writing is that there's a hidden variable in MRDCL called XIR, which increments automatically for each record for every error it finds. Now we've got no check statements in here, so XIR would by default be 0 for every single record. But if I put something like this, if $4 is a 5, or if Q1 is a 5, edit list outside my sample, so probably they're out of quota, if they're Q1 a 5, look what happens now. It's going to run, and I only get 1 record again. So it's a little bit like what happened when I filtered that write statement just now. It's excluding the record that had Q1 of 5, and that's because the record failed this test. It had an E on it. If I just put list, it wouldn't have failed it. It would have just listed it to the report file. But because I've got an E on it for edit list, it's going to say that XIR is now stepped up by 1 for the respondent that had Q1 of 5, and records only get written if XIR is set to 0. So when I have this statement and the 1 record that has Q1 answer 5, XIR got stepped up by 1 for that record, and therefore it didn't get written away, whereas the record that was code 4 did get written away because it didn't have XIR set to anything other than the value of 4. So if I want to, I can cheat. I can say XIR is 0 here for every record, and it will still write it now because it's going to reset the value of XIR. And you can see now I do get my 2 records back. And indeed, I have seen people use that. They want to put a lot of check statements in and then decide whether they want to set it back to 0 based on perhaps some control in the preprocessor that sets whether they want the run where they do exclude records or don't exclude records. I'm going to delete that for now. So that's some of the things that you can do with reading and writing. Let's move on to another example now. I'm going to move on to this example. Now this example is a little bit different, but it gives you an illustration of how you might handle a project where it's either too big or you've got your data coming in 2 different files. It's becoming more and more common that you get data where you want to merge data together from 2 sources. Now this is quite a simple example, and I want to say that if you want to go on to more complex example than this, you'll need to understand some of the more advanced commands in MRDCL to do this. But let's start with a simple example here. And let's look at the data that we're looking at here. So I'm looking at file1.asc, and that has two respondents in there, the one we saw just now with the 4s and one with the 5s. But I'm also this time looking at file2.asc, and here's some more information about respondent 1 that's come in a separate file where they've got 111 and 222. So effectively the data for respondent 1 comes from the first line in file1.asc and also the first line in file2.asc, and respondent 2 comes in the second line of file1.asc and the second line of file2.asc. Now, when I said it could be much more complicated, let's say you had 1,000 records here. What I'm about to show you will work absolutely fine if those 1,000 records are present in both files and in the correct order. I'd recommend sorting the files, or if they've come from a common source so that you know they've output in exactly the same way. If one file had 1,000 records and the other had 995, what I'm about to show you wouldn't work, because it's assuming I'm taking one from one file, one from the other, one from the next one from the first file, next one from the other, and so on all the way through the process. But let's see how we can read that. So let's look at this script. And here you see that rather than C equals file1.asc, I've got C brackets A file1.asc. So what that's telling it is I'm naming this data file A. You've got the letters A, B, C to use here. There is D available as well. And you've got a second file called B, which is in file2.asc. So I've got two data files here that are independent. They're not merged together anyway. They're totally independent files. Now I go through my script. I'm setting this time my card characters to 200. And I'm reading from the A file, file1.asc, and I'm putting it in the fields 1 to 100. So that's effectively reading from the A file and putting it in the first 100 fields. Then I'm reading a record from the B file and putting that in 101 to 200. Now I've got all my data in one string from 1 to 200 effectively, the first 100 columns being the file 1 data, the second 100 being the file 2 data. It's good practice when you're doing something like this to check that the serial numbers match, because if they don't match, if you didn't have them matching or they weren't sequential, you would have some quite serious errors because it'd be matching up records that weren't the same. So I'm just putting a check in here to say that if 1 to 3 is not the same as 101 to 103, I want to list an error out so that I can try and correct this. Now I can pick up question 1 from 4, and I've called this one question 99 from 104, effectively off the file 2 data. And now I can run those tables, and hopefully I get the 4 and 5 from the file 1. Remember, they were 4 and 5, and they were 1s and 2s in the file B, the second file called file2.asc, the B file, and we got 1 for code 1 and 1 for code 2 there. So it looks as though my script is working fine. So that's another thing that you can do, particularly where you've got data files you want to pull in from different places. So that's in the folder as well that you can have a look at. And the final example in this little section is how you can read what I call some of the legacy data that we get these days, either in binary format or in ASCII format. It's less and less common these days, but we do get data that's held in card format. And card format means storing data in blocks of up to 80 columns. So if we look at this record, record 001 has what's called a card 1. Record 001 also has a card 2, the 2 here in the fourth field there indicating it's a card 2. Record 2 has a card 1 and a card 2. Record 3 just has a card 1 but no card 2 because the survey may be ended halfway through for some reason, and record 4 is the same. Now ordinarily this would carry on all the way across here up to the 80th field, and because card-based data is stored in blocks of 80 columns normally. And so what MRDCL does with this is it says, okay, what's in the first card for a respondent? I won't store that in 1 to 80 or 1 to whatever it might be in the normal way. I'm going to store that in 101 to 180. The card 2 data I'll store in 201 to 280. And if there were more cards, it would be 301 to 380, all the way up to a possible 999 cards, where it will store it in 999.01 to 999.80. Now again, you can take control away from MRDCL there and decide to read different cards into different places. You haven't got to just read them where they are. There's been a few examples in these videos now where you can shuffle data around from where they really are. Alright, now I've got that data in that format, I can read it, and I can say the serial numbers in 1 to 3. I could have said 1-3 rather than 1,2,3, but that's fine. The card number is in the fourth field, so the card number is in the fourth column. It could be in 4,5 or 4-5. That would also be fine if it was a 2-digit number. And the card types I'm picking up are a 1 and a 2. The 2's in brackets because if you remember on the data, it was optional to have a card 2. So we don't want that erroring. If it was compulsory, we wouldn't put a bracket around it. But as card 2 is optional, we've said 1, bracket 2 bracket, and MRDCL will proceed fine if there's no card 2 there. And then we pick up question 1. So this is being picked up from card 1 on the 5th column. So 105 is not the 105th field, it's the first card, and it's the 5th column on that card. If you wanted something from the second card, it would be 205, and that would be the 5th column on the second card. We can run this, save our data, and run. And sure enough, it's read 6 lines in that file. It's written 4 records to the IDF because we only had record 1, 2, 3, 4. And here's our tables, 1 person saying yes and 3 people saying no. So we've had a good look round different ways of handling data, reading and writing data. Hopefully this video was helpful to you and gives you a few more clues on how you can process data and what reading and writing means in MRDCL. Thank you.